So if you install it, it will not work for you. I just wrote from scratch the final perspective because I just didn't like how AI sounds at all. So it even validates better than humans can validate. So there is basically no answer to that, right? So hello everyone. Today I am with Arif, who started this perspective.
Introduce myself first. Yeah, I'm Arif Ullah from Anhui University. I did my postdoc in Dral's group. So about this perspective, I think we started maybe 1 year ago, and at that time, many preprints they were appearing on this on archive and also in many journals. And then, yeah, at that time I actually started it, but kind of still the field was developing, and I was thinking the same burst and the same boom that was happened in machine learning. We are also seeing it here, but I didn't push it. And I think now that we finally put it online, I think this is the best time to put it to see how the field is going and what we should do in our field and how we should push it and how we see the future of this field. And maybe we should also think, the research, yeah.
Yeah, so as usual, we are always flooded with different papers. And back then, when I got your draft, I didn't think it's even worth spending much time on that. It was very, very in early stages, right? So now when we have
Yeah.
more than so almost 50, I'm pretty sure there are more than 50 already. We just what we surveyed is around 50 agentic systems. And after many years of fighting with these agents and getting experience with them, there is more for us to tell about the field. So that's kind of right time now.
Yeah, that's a good point that you mentioned that we also started working on our own, this Protomia and Aitomia agentic system, and from that experience now, we kind of we say we are kind of qualified and we can better judge the field, from our own experience and what are the problems there, right?
Yeah, because last year it was what maybe maximum at the beginning when you started to write it, I think there were only like around 10 different agents and very, very in the initial stages, I would say, right? So not something that people were using actively outside the group that developed them. So that was not much to overview, but now they're
Yeah,
becoming really so powerful.
yeah, and at that time, let's suppose at that initial stage, if we have published it online, maybe very few people, not many people would be interested. Yeah, people usually they don't see how the field is going, how much it is important. But now is you see there are many agents and many of the groups are working in this direction. I think now people will be more interested to see the trend in this field. Yeah.
Yes, the timing is very important because if it's too early, then people just are not interested in that or not think it's useful. Like we had this four-dimensional, this 4D space-time models for molecular dynamics, so it's still was too early. So when I look now at citations and when people look at that, that will be definitely the future. People start very big groups start working on that, but definitely we were a bit too early to produce that idea. So now it's kind of time to go back. And for this particular perspective, so the PDF is online. It's a CC BY license, so we can show it. Anyone can access it. It's not paywalled. It's preprint. And so here, what we've done first is to go through the literature, right, and try to find as many agents as we could. And even for literature mining, agents are very, very good, right? So that's why lots of or most of these agents, it's not just found by hand. So I have my daily literature checks, which I do semi-manually and also now with agents increasingly. So I know kind of when some new paper pops up and then so I had collection in my library, but now there are so many of them that it was necessary to employ agents to track them faster and start also summarizing into different categories. For example, when we decided to see how it works, like what is the trend, how fast it explodes, and to do it by hand, like to check every publication date, what is was published at which exactly date, it's lots of work, right? So now if you ask agents to pull out the publication date, and he is ordered by the first appearance, either as a preprint or already published paper, depending which is first. So it is very then objective. So it's not that we cherry pick something or try to put the date we like, and so agents don't have any motivation to highlight some of these. So like I just asked to highlight our models here to show that they were kind of in the middle of the pack in a way. So like Aitomi is one of the first general ones, but not the very first, and but among the first. And then Protomia now like was at the beginning of this year, 2026, when it started to explode. So it's also a big evolution of all these models. And I think when Arif sent me this first preprint, it was roughly at the time of Atomia, more or less, right? So like, or even so it's or even before that, it
Even
was pretty early.
yeah, before then, yeah, it was kind of like, yeah, some of the agents, they appeared as a preprint.
Yeah.
Yeah, like most of them were just preprints, just few of them. Yeah.
And then as a chemist, of course, we are interested what these agents can do, because there are many agents, yes, but when you want to analyze, like, can they do what I wanted to do? And many chemists, for example, are interested in transition states. And this is already a quite complex task for every chemist. And you see that only very few systems can do it, right? So, and I think only one can be done online, and that is now Protomia. I didn't see other models which you can access online to do that. And the same like for excited states, very few people do that. So most of people, of course, do structure generations, because that's how you start any computational chemistry. And there are plenty of systems. And another, of course, important topic is molecular dynamics and all this electronic structure, DFT calculations. So there is a huge field in DFT calculations. So overall, the field is shown here. Now, machine learning potentials development is also very important. So that will, I think, increase pretty soon a lot. And here, if you look, another very interesting observation is that, okay, there are many papers or preprints about agentic systems, but which one you can actually use? And not that many, apparently, because I was a bit also surprised, because many people have this preprint, so I was expecting that there are many more either like online web platforms for that, like SaaS, like we do have, or at least like some repository with it. But for repositories, maybe like roughly half of papers and preprints come with repository, and the license not always permissive. So like you have to be careful to check what is the license. And when AI started, so like my agent started to check whether you can actually run these calculations, right? So run these systems. So most of the repositories had some hard-coded passes to the the developer's computer pass. So if you install it, it will not work for you. And then when so in one repository, it found some unencrypted, so like just API key for some of the providers. So people just forgot to remove. So it means that when you do these agentic systems and publish online, so very few people can use them. And that's why, despite all this explosion, it's still not clear what you can use for yourself. So we can talk about our own platform which you can use. So if you go online, that's what I'm showing. That's what we used to even to prepare this perspective, right? So you go online, then you have this tag files we write in LaTeX, but it can also write in Word, and then you can compile PDF. And here's this Protomia which we also reviewed. So you can ask it to do something. For example, here I have my ask it to update my library with the references, and then it will do it, right? So then it can analyze this. And I think Arif also tried a bit to use it. So what's your impressions about that?
I think it's quite a good platform given the limited resources, and I think I found it very useful. So you can do many things with it. Yeah, like even general task and also computational chemistry oriented tasks. Yeah.
Yeah, so that's why it was our motivation to provide it for ourselves, collaborators, and overall community, so that you can log in and use it. And that's why it is very interesting to see the user feedback and what they use it for, what they want to use it for. And my observation was that most of people don't realize what it can do, right? So I still see that even in my group, so people come and then copy paste some of the scripts to, I don't know, DeepSeek or something like that, and then copy paste back it here. But it can run here simulations, right? So and if you have some script, so you can just drop it here, and then it will show here. Then you can just ask it to modify the script and run it for you, right? So it's like normal agentic system. So the biggest problem right now is that there are many platforms. How to like train people to use them is very unobvious, and despite all this flood of information, it kind of not making it easier, right? Because then you don't even know where to start from in some ways. So I don't know, like, if what's your opinion, but there are so many papers about also agents, and right now this general coding, like whatever we use right now is very powerful, right?
Yeah. The usefulness is kind of like, is a question. Like, people, okay, they claim, okay, they have published, they have developed some platform, but whether other users outside of their group can use it or not, that's a big question, right? Whether it is useful, yeah.
Even inside the group, it's like I see a problem, right? So like even if you have capable system and you have it connected to your calculations, so you just drop the calculations to analyze or ask to run calculations, and it's still much slower uptake than I would expect. And also many of this it might be explained because particularly in the research group, we develop something new, right? So at least in my group, so we don't use that many of the same calculation routines. So many groups in computational chemistry, they have pretty much established portfolio of what they do. So established like programs, quantum chemical programs. So they take like popular programs like ORCA, run some calculations with it, and they have already input files which pretty much work for every new system that they would run. So with some small adjustments, they will monitor it, how it proceeds, and then check it. So for these kind of tasks, it might be very good to have agents to do if they're repetitive. At the same time, it might be also very easy to ask any, like if you have Cloud Code or something to set up for users, right? And that's why it becomes a very good question for whom specialized systems are then developed, because people who know what they want, they can ask any specialized agents to do that. And then if you don't know what to do, then I think it's might be the most useful application of these agents, because many experimentalists, for example, they would help, so they would really love to use that. So and that's what I see. So also from if you're learning just to do computational chemistry, then it's very good, right? Because then it can explain to you how to do it, and all of these workflows that experts in coding these agents, they're verified by experts, right? So they will be pretty robust. So that's something that you might trust more than if you just ask any of your typical agents like online a GPT seems to to produce for you input files or something like that. So that's my big advantage for, I would say, for broader chemistry community, not just for specialists. For specialists themselves, it really becomes much easier to develop yourself with agentic systems if they need. So I might be wrong here, but that's my feeling, right? And in my group, we always develop something new, so very rarely use the same scripts. That's why it's pretty complicated.
So, what do you think about these, like you mentioned, ORCA or VASP or other these big softwares? So it's probable that these OpenAI, Claude, Anthropic, they will develop some agentic systems for that. And yeah, so people who are working in this direction, what do you see their future, and how do you compare it with very specialized in-house, like you have this MLatom. So if you develop agentic system for MLatom in-house softwares, so how do you compare and how do you see their future?
That's an interesting question because, like, if you look at the curve, so these new models become so powerful they just basically memorized papers and tutorials and code. And for example, for MLatom specifically, it's open source, so it might memorize it very well in the future. If you look at the trajectory, the first models like which were online when we tried this ChatGPT, for example, it didn't even know Gaussian input file structure, so it was producing something wrong. And so now all these models are so good that they are not making many mistakes in the popular software, because they found so many examples of it online that they tried very well. So you don't find many examples online about MLatom use. So you will find our tutorial and so on, but for neural networks and for these LLMs to remember that, they need to see many like from different sources, many examples, because it's basically weight of the training data. So they are still not that good in understanding the MLatom. That's one thing. But also MLatom itself is changing very. Now we really released just a new capability, right? So just this week. So they cannot keep up even training so fast as the models. So if they release some new model in a couple of months, then you will have to wait a couple of months until it knows MLatom, right? So for cutting edge research that again we are doing, then it is very different from if you use established methodology. So if you use something very new, then these models of course lagging behind, and then but they are again also getting increasingly good at just looking at the full code. This context window becoming so big that they starting to be really very good at like if you just drop MLatom GitHub page and they say, hey, produce for me some script to run some simulations, I'm pretty sure it will do it very well, right? But it will still not be as good as for established software, which is more widely used because, again, it doesn't know yet all the problems, right? So for these other programs, it also has in the training data set data what will happen if something fails. And it just knows this very often solution. For things like MLatom, if nobody like puts a resolution to some problem which they saw with MLatom, then it will have to rediscover it and solve it, maybe not in the optimum way. Right? So there is still some, of course, for this kind of software, there is still some use of specialized agents, but even then, if you write a specialized agent yourself, so you need a lot of testing to make it work very robustly. So that's what we see, because you can make, so like everyone has access to the same tools, but to make it really robust, it needs a specialist and lots of testing. So that's why that's still some what people
that's true. That's true, because let's suppose if we talk about Protomia, and because you are a specialist in this field, it goes through your validation, and then you make sure that whatever it's doing is correct. When it comes to like Claude or other general agentic system, and if they use MLatom, how to ensure that whatever it is doing it's correct, especially for a newbie student in this field, right? So so there are many agents. So let's talk about the Protomia. What is Protomia and what capabilities it offers to the users? and what are the challenges, future challenges?
Yeah, so Protomia is, I just showed you online, so how does that look like? So you saw this print itself was helped by Protomia in preparation. I have to admit that at the end I just wrote from scratch the final perspective because I just didn't like how AI sounds at all. So I used the data. It found I looked at the data to see that. So I had to decide also how to categorize and everything. So there's lots of my human input into that. So it helped to prepare the database and everything. But I have to admit that I did end up rewriting it because it is a question of taste and style. And that is something that agents will have to fight a lot with in the future, right? So it's how to make it so that you like it, what it produces. And that is not there yet. So I didn't manage to make it write exactly like as I would write, and maybe just impossible, right? Because it's my head, so it's what is in my head. It's just I know, right? Explaining to an agent it is more complicated than writing it myself. But when you talk to
everyone has a different style of writing, like a different taste. So so it's hard to
Yeah, but for definitely like I was talking with lots of students, for example, for them to write something is a big challenge. They have to learn that. So like, of course, for me it's easier to write. I just see it. So like to write this perspective, I spent 6 hours. So I measured. So like to write, of course, after all of these variants, so like versions and check it. So it's not that I was writing on the blank page. But asking to write any junior scientist, like early career scientist, in 6 hours is impossible, right? They're not going to do that. So it's like I have hundreds of publications which I was writing at some point. So it's really lots of expertise. So for junior and early career scientists, definitely it helps to produce decent drafts. And then one key of Protomia is that it's not like any chat that just produces your text. No, so it's actually is grounded to the truth, ground truth. So it will go back to the data, like your calculations. It will check output files, and then it does it in a very good way, which I made sure works. So it doesn't make up any numbers because it just pulls the numbers from the actual calculations, and the numbers it puts in the paper all checked. So after it even validates better than humans can validate because if you open like .tex file, you will see that it puts in commands validation for every sentence. And then very often, like humans don't even do that because then you find some mistakes later in human papers. And there was one very nice news in Nature, so I was sharing with Arif some time ago by our friend Sebastian Pios, right? So they interviewed him, and basically the article was in Nature that AI helped to find mistakes in the 100-year-old like papers in experiment, or it can do the same for our paper. So it's really validates very good. So I would trust Protomia's written paper more than I would trust a paper written by a human many years ago, right? Because it does check every number. So sometimes you have even to a problem that it becomes like too slow in terms of sometimes you just want to rewrite something small, right? And then it starts spending lots of effort to go like to and double check that it doesn't change the science and change the numbers. So there might be some middle ground there, but it's what it can do. So like if you have to do some calculations from scratch, then it does these calculations like here for some this other reaction, and then if you have to write a paper, it will summarize it in a paper. So that's what basically Protomia can do overall, and all these capabilities. So if I show here Protomia, so there is some list of features, so you can check them. So like from single points, obviously geometry optimization, frequencies. I mentioned transition states that can do this, like NAB search and so on, dynamics, exactly states calculations, so many different things, and run it all on cluster on HPC.
Oh, cool. So maybe we are getting in to the end of our, this podcast. So one last question, maybe that what is the future of doing research? Like, especially if you suggest, what is your suggestion to the students in quantum chemistry?
Yeah, that's the toughest question, and as I think we have in this perspective also reason. So there is basically no answer to that, right? So I don't have answer to that specifically. I can tell you what right now I see is happening, right? So this also figure which we put pretty much summarizes it, because in the newer papers you see that it starts using these channel coding agents more and more, right? So, and then it starts doing more and more autonomously, like from before it was just one calculation, maybe geometry optimization, right? So now it can do the whole series of like calculations, basically in silico experiment, and write papers, you know. So for new students, it is the most challenging question. I will say do something mostly now for fun, because you have to, it's kind of going back to what science is supposed to be anyway, right? So go to find the roots of like the problem, scientific problem, right? So what is the reason for the processes, like natural phenomena you observe? What is how to what is defining the properties of your material? So it depends on, of course, on your interest, so find your interest. And these agentic systems are now opening you the doors to do any kind of science you want without spending. So you do not need to spend now so much time to learning hundreds of like papers and reading many books and going through many tutorials, because whatever you have in your mind, you just ask an agent and basically it can check for you very fast and so on. So, and it is basically now really into going deeply into something you like to investigate, enjoying the process, enjoying the learning process. And in this respect, agents can help you a lot to produce lots of interesting findings and science. How, again, overall, like we write in the paper, we don't know how much might be it is useful or impactful at the end. That's why you still have to talk with your supervisors to who might have better assessment of the overall field. But it basically enjoying mostly now doing science and doing what you like to do. So in my group at least, it's pretty much like that. So everyone can do what they like most to do, and then they just exploring. So we discuss what they're exploring. We discuss them. So now our discussions shift mostly from technical discussions. Like before, there were lots of technical things like how to do this or is it possible to do. Now it's more about like what we want to do, how we want to do. So like what is a scientific problem there? Basically, in exchange of interests and like most like a collaboration. So it's very different.
Yeah,
So what
yeah,
about
that's cool. So,
or your
so
opinion?
what I think is, yeah, so what I think is like if you have any idea, so you don't need to spend so much time to like, to validate it and okay, test it, whether it's working or not. Yeah. So your AI just can really quickly test it for you, whether like, it is working or not, is it feasible, and whether it is worth doing or not. So yeah, that like it makes this validation and testing like quite fast. But second, I think for the students, I think in this AI agentic system, this human expertise to judge the output of the AI, that is most important. So I think students should focus on this expertise so they can validate and understand the output and judge the AI output. If they don't have this expertise in this, okay, and if they just learn like before this AI agentic systems, okay, they learn how to run calculation using some software, but if they don't have this ability to check and validate the results, then that repetitive work can be done by AI agent. So you will be like, obsolete in this field if you don't have those expertise. So that repetitive work can be done by AI. Now, students should focus on expertise in understanding, the deep understanding of edge and validate, and what problem we should use AI, and what are the applications. Yeah, I think that these things are more important.
Yeah, that's a tricky question because again, I don't have an answer to that because I see how things change very fast. So before, definitely many things you need an expertise in terms of judging where it's correct. So it's still necessary right now, right? That's why whatever science I am doing, so it's the same like whether a student is doing it or AI is doing it or I myself doing it. So like at the end, I have my what I call common sense, but this common sense is based on lots of also intuition of how physics and chemistry works, right? So then I just understand that, and then if some result is really very off from what physics allows or chemistry is supposed to work, so then it's a flag something is wrong, and then I would it's immediately like intuition flag something is wrong, so I have to check. So for a student, it doesn't work this way unless they have many years spent to gain this expertise. So it's kind of a chicken and egg problem, right? Or circular problems that you have to judge whether it's AI producing something. All right, you need to be an expert. If you don't have an opportunity to get your expertise without AI, then how can you judge it? So in a way, like I said, that you can use AI to get something correct, and in most, or at least now I see in many cases, it is really very, very robust in what it produces, right? So it's getting much more accurate and correct. It's even has its own doubts about some results and double checks, right? So that's the agentic systems I developed work exactly this. They question basically every claim. They go back and check and every number. So for students, it's very, very hard to get it without making lots of mistakes on their own. So that's why it's very tricky. So maybe some part of this, while you have to use AI to get ahead, at the same time, you might want to dedicate some time to do something by hand, learn how to do that. For example, it's like sports, right? So like once we have cars and lots of transportation means, we take a run, we go for a run, we go for a walk, right? Because we want to we go to the gym to exercise our muscles because we don't go and work in the field anymore much, so that we need to that we train our muscles. So now we train it explicit, like with the specialized, dedicated routines to make sure we kind of in shape. The same for brain. So like we also teach kids in school how to multiply numbers and how to memorize some like poems and so on to train their brain. So the same way, like if you totally drop your training of the brain and just rely on AI, it will atrophy like any muscle. So if you want, especially to develop some new skill and to understand how it's done. So right now, why I, for example, rewrote from scratch this perspective, because it doesn't matter how I was writing, and it just doesn't sound like good, like or like what I want to say. And very often, if you use AI as a junior or like early career student, then it produces something which looks scientific and complex, but it's definitely not somebody any human can read, because it's just lots of text which every word kind of makes sense, but put together it's just too complex to read. So the key is how to write this easy, what is a good writing is, and that you cannot get unless you start reading what is good writing is, unless you look at the good papers before compared to what is AI produced or you produced. And if you don't dedicate some time to sit and maybe write this pen and paper at the end, right? So because how to force you to train these skills. And I think that something that the best specialist will end up doing many things still by hand, just to keep the expertise. That's why I rewrote this perspective, and I will still keep writing now. So I just feel that I just want to write, and I have to write just to keep myself sharp to write anything. Otherwise, if I just rely on AI, then I sit to write something, and then I have this writer's block because I don't know how to write or what to write. Right? So you have to train the skill. The same like for calculations and everything. So you cannot just rely fully on AI. So you need to check, like yourself, go sometimes check these numbers, run this calculation by hand to not lose the expertise. So that's kind of part of what is university for, no? To train the skills.
So exactly. Well, I think nowadays it's quite a challenge like when you teach in the class and you give homework to students, they usually just use DeepSeek or ChatGPT, to do their homework, and then they just don't bother to learn themselves. So it's quite a challenge. I don't know. I also don't know how to handle this situation. Like, yeah, you're right that okay, you should have the judgmental skills. Okay, you ask AI agent to write a paper for you summarizing your results. Okay, you run some calculations and then okay, you say okay, ask them to summarize or write me a paper about these results. But how to judge whether the writing is a high quality? It's a good writing. It needs expertise, right? And for expertise, you need to writing many papers yourself to get those expertise. So it's quite challenging, and as you mentioned, no one has any answer with where this field is going. So
so with
so let's
this,
see.
yeah, so that's why we finish what we said. So let's see where this field is going. So